let's start with the introduction. So in this work package, we have the 4.2, which is the one that we are currently working on, where we are developing a repository of best practices related to regulatory sandboxes, living labs, and test beds across clean tech, deep tech, and smart city domains. And to do so, what we are doing is gathering information from our own experience, from talking to leading hubs, as well as from public sources to get to this repository that we think can be useful for the different innovation ecosystems to get inspiration on what's out there. Think of it as anything that a company in clean tech sector may need across the whole development cycle, from ideation to commercialization. And after that, so we are doing these workshops where we aim to present part of these best practices, as well as to provide some space for brainstorming and applying them to your specific ecosystems, and to share them with other ecosystems to potentially create collaborations or share ideas. The final goal for all of these different pieces is that all the 6 FINEX ecosystems to walk away with an enhanced capacity to identify, test, and validate deep tech by understanding how these best practices from leading hubs have done so, and also reflecting how your own ecosystems, resources, competencies, and capabilities can be used to replicate these proven practices. So let's then deep dive already into what are these best practices. So we have split them into early stage testing, late stage testing, and then location and amenities, which apply to both early stage and late stage experimentation workspaces. So early stage, we have defined early stage. Well, you can think of labs, maker spaces, test beds. So they are dedicated environments for the development and testing of early stage clean tech innovations. And like more generic co-working spaces, these spaces must accommodate hardware experimentation. So that means that they will obviously contain something like a maker space, wet labs, dry labs, and things like this to validate prototypes. And they need to be fully equipped. Some of the classic equipment that we see is 3D printers, welding stations, oscilloscopes, and then also specific utilities they may need, software, and IT infrastructure. So in terms of challenges that we have identified specific for early stage experimentation workspaces in clean tech, is that they are hardware heavy. That means that they need these physical spaces to develop solutions. They tend to have longer development cycles. Normally, it's about twice the average for software. So that's also a key challenge of these solutions. And then the range of needs. Yeah. Noah, do you have a question?
Just to quickly clarify, I think you said the challenges that we identified in early stage testing spaces, but these are the challenges faced by early stage deep tech companies. Like why does it take them longer to, or what are the challenges that they have that are unique to deep tech? And it's as you were saying. So I just wanted to make that clarification. That's it. Continue. Sorry about that.
Yeah, good point. Yeah, exactly. So what are the challenges that the companies face when they have the need to go to an actual experimentation workspace? And another one, as I was saying, is the range of needs that they have is very broad. You can think of the needs that an energy company might have, which are completely different from a building environment company, a mobility company, or even a water company. So that's also a key challenge. And the final one that we have seen is how rapidly evolving these technologies are changing. So a good example is the maritime industry, where it's still uncertain what's going to be the standard solution for ship and boats propulsion. If it's going to be hydrogen, it's going to be electric, wind supported. And so this creates some uncertainty that makes it hard to plan long term, and also to have some security on what's going to happen, and therefore having some changes. Some of the key attributes that we have seen that support addressing these challenges are try to make it affordable. And the idea to make it affordable is look for shared versatile workspaces that are optimized for high collaboration. And to do that, we also recommend to select a specific audience in terms of sector, TRL, business function. Then also to make it customizable, it can be through a modular design, movable partitions to adjust the layout, or flexible terms in terms of like what they can get if it's a shared, a private lab, so that they specifically tackle their needs and they don't pay for more. And finally, we've seen the sustainability aspect. So many of these workspaces, to be aligned with our mission, they tend to be green certified. They tend to be energy efficient infrastructure, and also potentially also serving as living playground for some of these emerging technologies. Now moving on to specifically for this early stage, some relevant examples that we have identified and talked to are the Scale Space that you can see on the top left corner, and also Greentown Labs. So Scale Space is an innovation hub in London. It's part of the Imperial College, and it is located in the White City campus, where corporates, startups, and incubators coexist together. One of these actually accelerators is Undaunt, that you see their logo right next to it, which belongs to Imperial College as well, and supports startups that enroll their program by letting them use their space for the first 12 months. And then the other example is Greentown Labs. So Greentown Labs is actually the world's largest climate tech hub. They have 2 physical hubs, one in Boston and one in Houston, and they have a very strong ecosystem connections like Harvard, MIT in Boston, or the energy sector industry in Texas for Houston. Now, some of the best practices that they have developed is in terms of spaces, they both offer state-of-the-art life science labs and makerspace, which are designed for good value for money. They have clearly defined the criteria of the tenants that they are looking for, so that these needs are contained to some extent, and that's by limiting to TRLs 4 to 6, and also having shared spaces with high occupancy in segments like climate tech, decarbonization, and renewables. Then they have also used a modular design specifically for Scale Space. There's a relevant example because they have built these buildings to last for 10 years, because they assume that needs are going to change so fast that within 10 years they may need to update or change the infrastructure that they have, and also to be customizable. So they offer private and shared labs. They have movable parts to adjust the layout as needed, which is particularly valuable when startups face cross-contamination risks, they face confidentiality requirements, or also if they need to control access to their workspace. And finally, sustainability. So, for instance, Scale Space has been BREEAM certified, which is a UK certification that assesses the performance of new and existing buildings in energy, water, health, and pollution. Moving on to equipment, tools, and supplies. So they tend to offer both basic ones like welding or sewing, and then also sophisticated ones more like into the fast prototyping, which they include 3D printers, basic electronics, or microscopes. The idea is that they offer these basic ones in shared spaces, and then they also have processes in case there's an innovator that has a specific need, so they can get extra ones on demand or via partners of the ecosystem or external services. Another best practice is to use a pay-per-use model to specialized tools. So for instance, 3D printers, CNC machines, which normally require of expensive consumables. So tools that wear down when you use them, protective garments, and the idea is that they only pay for the ones that they have actually used and not for the whole investment that requires to get this equipment. And then finally, there's the negotiate bulk purchasing. So instead of everyone getting their own stocks, especially for the basic ones, to getting some solutions. A very innovative one we've seen is when they implement inventory management through vending machines. So we've seen some of these hubs having vending machines for solvents, which is automatically restock every week or so from an external service. And this makes it also available 24/7. So if they want to stay late night or any random hour and they have the need for some of these stocks, they can access them. And finally, in terms of utilities, retrofits, and software. So normally what we've seen is that it's very important to adjust it to the exact need. So that's why they request for continuous feedback to tenants, and they do so by constant surveys or maybe through an app where they can provide feedback and to adjust, upgrade, or downgrade things like electrical capacity, purifier air feedstock, or other expensive inputs. And then, so the idea is that with all of this, they adjust exactly to what it's needed for most of the tenants. In terms of software, something that we've seen is arranging a specific workstation where they preload some of these softwares that are normally very expensive, like SolidWorks, MATLAB, or even like with some credits on digital tools or cloud credits, so that the different startups can use it and benefit from it and only pay for the specific amount that they have been using and not the whole package. These are in terms of early testing. Now, moving into the later stage, some of the key differences from early stage is that now we are talking about testing solutions under real world conditions and by real world users in the case of living labs, as well as under specific regulatory frameworks in the case of sandboxes. These are very important experimentation spaces, especially knowing that there's this gap between prototyping and commercial scale in clean tech technologies. And they really support in innovation not remaining stuck in this prototype stage, which is something that we've seen quite often. What are specifically the challenges that innovators face when trying to get to late stage experimentation spaces? So the first thing is that they are large scale and they are expensive. We're talking about wind tunnels, water tanks, expensive testing elements like fire or acoustic for building materials. They are also very specific to the technology. So unlike early stage, now each of the technologies have very specific needs, and we don't have some common trends like fast prototyping that we had in the early stage. They also have complex setup and know-how that is required to create these spaces. So imagine, for instance, if you want to test something in a coastal area, you may need to prepare with a net to make sure that there's nothing that's going to the sea. If you may want to test something on energy, you may need grid access and permitting, and then also to make sure that it's tested in a safe and proper way, knowing that it's a very expensive equipment. So these are another challenges. And finally, regulation and policy. Sometimes regulation is maybe not even taking into account these new solutions, or they need to allow for some space so that they can properly test them. And some of the key attributes now to address these challenges. One idea is outsourcing. So normally via ecosystem partners that have industrial facilities, large facilities that they can access. Another idea is urban test zones. So this would be with city councils that offer districts where specific solutions can be tested. Campus demonstration facilities that sometimes include smart homes or microgrids to test solutions. And then also finally some public infrastructure. We can think of ports, for instance, where there's one of the examples is actually related to that, to test some maritime solutions. Another key attribute would be subsidizing or getting paid pilots. So this relates to joint innovation with corporates, which taps into their expertise and the access to their facilities. And then operational and regulatory support. So this normally, as we said, they tend to have a very complex setup, many times require for approvals, and having someone that supports in that space to adapt policy and regulation is essential. And now we will see some of these examples. So real life examples and best practices that we have identified. We have seen two main relevant examples. So one is the city of Tallinn and the Test in Tallinn program, and the other one is BlueChem. So Test in Tallinn, which is where the city itself serves as an urban living lab for smart and green technologies. And it was launched as part of Tallinn's innovation strategy. And the program invites actually startups and scale-ups to use the city as a work and experimentation space instead of just waiting for mature solutions, which is what common city councils do. They have already tested more than 40 innovative projects, and the program kind of provides a one-stop shop for regulatory and logistical support that we will see in a minute. BlueChem instead is a sustainable chemistry hub. It is based in Antwerp in Belgium, where there's the largest chemistry cluster in Europe, and also they have the port of Antwerp, Bruges, and a whole business park around it. So it's really co-located with some of the best or like the most interesting ecosystem actors to really develop the clean tech solutions. Now, specifically focusing on demo spaces and living labs, BlueChem is actually a very good example. So what they have done is to act as a catalyst, connecting startups in the biotech, circular chemistry, and advanced materials to some of the corporates in the chemical cluster, like BASF, ExxonMobil, and the Port of Antwerp. And a good example is specific startup that they supported, which was developing a technology to convert CO2 into carbon monoxide, high purity carbon monoxide, which is used for some of industrial processes. And what they did was to connect this startup with some of the corporates, and they built a whole consortium with BASF, NG, and some other large companies from hard to abate sectors to build a whole demonstration production line that would take the CO2 from these different corporates and convert it into carbon monoxide. This is something very expensive that the startup itself, or even like with the support of the incubator BlueChem, wouldn't have been possible. And then an example from Test in Tallinn, again, to do some living labs demonstration. It's when they supported TrackDeep, which is a startup that developed AI-based drone detection systems. And to do the testing, they actually needed to install sensors in various buildings of the city of Tallinn. And Test in Tallinn, what they did is they granted 1 square meter for all the 21 city-owned buildings. And they also coordinated and executed all the lease agreements simultaneously, which is normally would be a bureaucratic nightmare. The fact that they acted as a one-stop shop and deal with all of this made this whole testing of drones in the city of Tallinn possible. Moving now to regulatory sandboxes. So the idea here is exactly so real life conditions via relaxation of or exemption of certain rules. And the key criteria here is to make sure that there's a clear eligibility. So what will be needed to adapt, and involve early on, as soon as possible, relevant parties. Here, a good example came from smart cities from the FINEX, which they are actually engaging 2 reps from regulatory bodies to support and anticipate these regulatory needs in the process. And so if they see that this is not going to be feasible, they would flag it way ahead, and this way they would save time and efforts. And then another key aspect is agility. And to provide this agility, a good way of doing it is by empowering entities. A good example is Accelerate Estonia, which is a governmental policy innovation lab that has developed and shaped some key processes in order to speed up the process for innovators so that they can actually test these solutions and to save time and effort to policymakers and reduce their workload. Some examples include changing regulations to be able to have self-service pharmacies without needing a pharmacist in place, which is part of the current regulation. So they have managed to adapt those processes to be able to bring to life some innovations. And finally, permanent regulations could be an example. This is the case of Port of Antwerp and Bruges, which has a pioneering regulation in remote operations of drones, ships, and industrial automation. And this actually has supported flights of drones for various purposes, including infrastructure inspections, environmental monitoring, and security surveillance. And the fact that they have this regulation in place, and it's the only place in Europe that currently has it, it supports attracting innovative solutions that can only test in that specific area. Very quickly, the last one, location and amenities really applies to both early stage and late stage. Some of the challenges is that clean tech requires close collaboration, and the fact that it's hardware heavy means physical proximity, not just digital collaboration. And this is key to really make these connections fast and speed up the already long development processes. And then another challenge is that the community spends a lot of time in person working there because of the tangible stuff or like hardware stuff that needs to be done. They spend long hours, so there needs to be a decent amount of amenities to really cover their basic needs as well as the ones from visitors. Best practices and key attributes to deal with it. The idea is to locate these experimentation hubs close to relevant actors. This can be academia for talent, industrial players for know-how, facilities and key infrastructure like ports, real estate, etc. Also to make it accessible, aiming for cheap and short commute for the members that go there on a daily basis, as well as for visitors coming from abroad. And finally, make it affordable and available. What does it mean? Well, the basic needs that need to be covered. And one that especially stood out was the nursery. So many of these innovators and founders tend to be young parents, and it can be a deal breaker for them if they don't have a place where they can leave their children while they are working. So these are key needs that needs to be supported by the experimentation spaces. Two relevant examples, again, Scale Space and Bluechem that we know already. Both have been located in places where there's vibrant talent pools. So Scale Space is in the White City campus next to Imperial College. Bluechem is also co-located with a chemical cluster and a business park, as well as the port. In terms of access, some best practices have been subsidizing public transport tickets or try to make the commute affordable and below 1 hour, which tends to be kind of limitation that we've seen in most areas. And then in terms of connection, so connected to nearby urban areas and having an appealing environment. So for instance, a good example is the city of Antwerp that has integrated the area where Bluechem sits into its broader urban development programs. And they have established a 14-hectare green ecological corridor that connects a nature reserve with the city greens belt, and it also encompasses the Bluechem hub. Some amenities, basic amenities like the ones we mentioned, nursery, canteen, cafes, gym, and then also housing for people who's working there. Some examples is reserving residential units at subsidized rents, or even going as far as leveraging student dorms for researchers to be able to stay there for certain periods of time and then be able to work on a daily basis. And for visitors, mostly hotels, business amenities like conference halls, restaurants, and catering. And having reached this point, now we would be just moving into the activity. So the idea is that with all of this in mind and some ideas that have dropped, to be able to start mapping what are the resources that you have in your own ecosystems, as well as what are those that are needed. The three main dimensions would be physical infrastructure, programming, and partnerships. Today, we will only focus on physical infrastructure.
Again, the whole point of these three co-creation workshops is that it kind of like works in synergy to help you guys develop a plan or maybe a light plan, a blueprint onto how you can do a better job to support deep tech in your innovation ecosystem. So the next one is on programming and services. Now we talked about the physical infrastructure, or what type of acceleration services, what type of talent services like business professionals or technical professionals do you have that support entrepreneurs in your ecosystems, et cetera, et cetera. And the third workshop is connectivity. And that's a super important one because maybe you have great lab spaces, but you don't have entrepreneurs going to them. So why is that? What can you do to help increase the awareness of your facilities, increase the connectivity between the various parts of your stakeholder community, et cetera? Thank you very much again for participating. We hope to see some of you on July 21st. And yeah, we'll be in touch and let us know if you have any questions or comments.